Akash plays a very interesting role for a company like Nvidia, and they understand the value. So they integrate a fine-tuning as a service product to demonstrate that, look, you can actually use underutilized GPUs, and that's working out really well. ChatGPT own employees admitted they look at user logs, which is stupid, which doesn't give me enough confidence that they're going to keep my data private.
In the future, do we have a generalized model that is good at everything, or do we have a model that's very good at utilizing specialized models?
That's $1 billion question everybody's trying to answer. I want to see human civilization reach type 1 status in my lifetime.
Hey, Greg.
Hey, Seb.
How's it going?
Great.
How's your Cosmoverse? Day 2.
Very productive.
You just gave it.
Day 1 was really productive. Day 2 was very productive. I didn't anticipate. I came with very few expectations, but the outcomes are exceeded expectations by a margin.
Yeah.
So,
yeah, I think my expectations were met. I mean, there's been a lot of Cosmos FUD. Yeah.
Sure.
And my expectation was that the community would be kind of feeling that FUD a little bit and kind of coping with it and dealing with it. And that's definitely the case. But I think it's positive in the end, because what we have here is there's really the people here are the people who are really building and like who are going to move Cosmos forward in a positive way. And when I say Cosmos, I mean like the infrastructure, the ecosystem, IBC, the Cosmos SDK, and also to some extent the Cosmos Hub. So yeah, I think it's positive. It's like this is the bottom. Like the AA DAO as a T-shirt, can it get any worse? Or can things get any worse? Yeah. So
no, I like it. I like
only up from here.
I like how, I mean, it's not very small, yet it's not very large.
Yeah.
It's like, I think 1,000 people or 1,800 people came.
Yeah.
So I like these small, intimate conferences more than the Token 29 or Token 2049s or whatever, right? Like
crypto
it's
carnival.
Massive. Like you don't get to do much. I mean, I guess you do a lot, but you don't get much done.
Yeah.
Is my feeling when you go to the large conferences. But this format, I could meet people that I wanted, run into people on the floor, have amazing conversations, and Cosmos is still very pure.
Yeah,
I mean, sure,
I tweeted this.
I tweeted that pissed off
Cosmos is still pure.
It's still very pure in the sense there's no meme coins and there's none of this like let's go launch a token and pump.
Yeah,
there's still a conversation.
I mean,
I hope not. I mean, it's still pure, right?
I have some insights into some.
I'm pretty sure it's coming, but it's still very. It's still very like, how do we build things that work? And in all honesty, I think like Cosmos Stack is very mature, right? Like, I mean, not because we use Cosmos Stack that I'm biased, but in actuality, Akash launched 4 years ago and hasn't gone down a single time.
Yeah,
we saw what happened with Terra. I mean, Terra worked, for all the misgivings, Terra worked phenomenally under stress.
Yeah,
right. The Cosmos Stack really works. Technology is very mature. And now we are seeing Cosmos being adopted, at least Cosmos design being adopted by pretty much everyone that, has an appchain thesis, right? So
I was talking on a panel earlier, and one of the takeaways was that, and out of context, this is going to sound really weird, but Cosmos is the ISIS of crypto. And what we meant by that is that like Cosmos is like super resilient, and like through thick and thin, there's this very like resilient ideology, and once you're sort of in it, like go and you don't stop, right? And like conquer.
It's a cockroach of crypto.
It could also be the cockroach of crypto. Yeah, that's another way to put it. Yeah, in context, it made more sense.
Of course,
but
in a nuclear cockroach.
Yeah,
nuclear.
So
winner.
Yeah, you guys have been up to a lot. Like I feel like I was using Akash with this like really kind of clunky, terrible client in 2021 because I wanted to host some websites, And it was like, I think I was texting you at that time or someone else on your team. And I was like, man, like this thing like just drops every couple of days. Like my website's not working anymore.
Really?
And this was like 3 years ago, right? I mean, but I just saw the potential for this platform to, be used for other use cases than just kind of hosting Docker containers, which is still a cool use case. So yeah, what's happened since then? I mean, give us sort of a...
Well, last 3 years, quite a lot, but in particular, last 2 years, we launched GPUs.
Yeah.
Now, fortunately, coincided with ChatGPT launching.
Yeah.
But we had GPUs on the roadmap since 2018, right? Just took a long time to get a decentralized GPU network working. In fact, some of the code we wrote for building Akash was used by Nvidia to build a Kubernetes driver, which we in turn used that code. So our code went full circle back to us. And that's what it took to really enable GPUs on a Kubernetes-based setting, right? So
in Kubernetes.
So Akash depends on Kubernetes on the back end.
Yeah.
And so it's been great. It's GPUs now account for the most of usage on Akash. Today we hit all-time high, like me at a conference, right?
Yeah.
We slowly rolled out a new feature that enables user onboarding fairly quickly without having to need crypto. So I think a lot of the in the last 1 year we got record growth. I mean, we grew quarter to quarter. I mean, year over year, quarterly growth was about 1,700% in daily fees, in user fees. That's a whole order of magnitude, right?
Yeah.
In a year, and we're able to attract really major players. And Nvidia now uses Akash. I don't think Nvidia uses any other crypto protocol.
So what are they using it for? I was gonna ask you, like, who's using Akash?
Yeah.
I mean, because like we see the token.
Yeah.
But I mean, there's actually people using it.
Oh yeah, and people talk about it on Twitter quite a lot too, and how much you see. But Nvidia now is the biggest user to a degree. We have Nvidia has a product called Brev, which is a fine tuning as a service product. So it lets you fine tune fairly quickly. I mean, set up all the necessary software and give you a container with the PyTorch instance. You can just run your fine tuning job, and that runs. And they use Akash for it. Okay. It's very interesting because Nvidia, I mean, of course, they own the GPUs. I mean, they have a lot of GPUs. So last to check, but their GPUs, they have hardware. I mean, they have the devices, but they don't have the cloud capability. They're not a cloud company. Yeah. They're a hardware company, right? Yeah. They're a chip maker. But the customers have the GPUs because they sell these GPUs, and a lot of times the customers don't use the GPUs, right? So, maybe they're between training runs, or maybe they have an older version of GPUs that they've upgraded to a newer version. There are lots of underutilized GPUs out there, and Akash has the capability to federate them and offer them at a significantly lower price than what you would otherwise pay for a new GPU, right? Yeah. So Akash is a used GPU market. So Nvidia,
eBay of GPUs.
It is EBA. It's Airbnb of GPUs or eBay of GPUs. It's without a physical delivery, right?
Yeah.
So Nvidia, no, because of the shortage of Nvidia GPUs, because of the demand, they're seeing other GPU providers, be it AMD, be it TPUs, be it even Intel to a certain degree, get prominence because now researchers that don't have too much money are the ones that are innovating to move to Nvidia to move to AMD. So we see the rise of AMD 350s coming up, and that's threatening to Nvidia's dominance, right?
Yeah.
So they want to keep their researchers on Nvidia chips. The only way now is to look into underutilization because they cannot produce more chips fast enough.
Yeah.
So Akash plays a very interesting role for a company like Nvidia, and they understand the value. So they integrate a fine tuning as a service product to demonstrate that, look, you can actually use underutilized GPUs, and that's working out really well. So Nvidia is a big user. Second big user, one of the big users is Venice AI, Eric Voorhees' new company.
Yeah.
They use quite a lot. In fact, I mean, their entire infrastructure runs on
Their whole infrastructure runs on Akash.
I would say not the web infrastructure, but
Right,
the
GPU
yeah,
infrastructure.
yeah.
That's cool.
The GPU infrastructure, I would say like 90% or so.
And they built their own models, or they're using.
They use open source models, but they also have an amazing way that ties these models together.
Okay.
Multimodal capability, right? So
they might be using like, I don't know, Llama.
Llama 3.1. They use news research version of Llama, which I think is much better. They use a whole lot of models. They use Flux for image generation. They use a whole range of open source models, and they give you a privacy optimized or privacy preserving, rather, censorship resistant chat interface. It's beautiful. I use Venice as my primary chat interface more than ChatGPT. I switch away from ChatGPT. It's the pro version of Venice, which gives you incredible superpowers.
Okay.
And it's private because I know they use Akash, so I have this confidence that they're not like listening to me and they're not recording logs, So I use Venice for my health data. Like, I don't give ChatGPT any health data because it remembers.
Yeah.
If you know, but ChatGPT, I mean, their own employees admitted they look at user logs, so which is stupid, which doesn't give me enough confidence that they're going to keep my data private. So I like Venice a lot. And then we have a whole lot of researchers, a lot of universities, because a lot of them are priced out. UT is a big user. Texas, Rochester Institute of Technology is a big user. In fact, they're developing. They train a new AI to be a what do you call office hours for their new class that's coming up. I think RIT is the first university to do so. So the new undergrads, the computer science undergrads, are going to have a AI tutor to complement the classes, which I think is phenomenal. And each of them are going to get Akash accounts to run their training jobs on.
What does this kind of like custom tutor model have more than like GPT-01 or like some advanced model?
So they fine tune the model on the class curriculum, so it can address questions There's more.
They'll take an existing model and then they'll fine tune it on some content.
I don't know exactly what model they use. I mean, they haven't disclosed those details to us, or maybe they have, but somewhere in the logs. But it's a good use because they're priced out of the cloud. It's university that they don't have too many funds, and the students don't necessarily have the money. So Akash is a great alternative to them. And then we have another big uses of Akash right now is decentralized training. So you have companies like News Research. News is a big user of Akash. We have companies like Private Intellect that have cracked the nut on decentralized training, which I think is phenomenal. So for context, training so far has been predominantly low latency, high bandwidth ODL. In the sense, to do any meaningful training, be it GPT-3 or 4 or Grok, as a matter of fact, required high density compute to be collocated and connected with very low latency. So you need really interconnect interconnect 3.1 or like these are very, very fast connections that have chip-to-chip connections that don't go to the motherboard, right? So because the way neural networks work. So distributed training was not possible. Even though there are GPUs spread everywhere, you couldn't leverage them for doing training. You can use them for inference, maybe fine-tuning, but training has been predominantly very, very localized large clusters. Now that changed. So News Research was the first company to do a billion parameter model, fully decentralized, and they invented a framework called Distro. I think Distro stands for decentralized training on the internet or something like that.
What does that mean? A billion parameter model, like compared to like a GPT or some other model that people are familiar with. The non-AI nerd.
Yeah. So Falcon, GPT is. Can't remember. I think GPT is I think GPT-2 was 100 million parameters.
I
think GPT-3 is a billion parameters, if I remember. Don't quote me. I don't remember. Not top of my head, right?
So the parameters is just the scope of the data on which it's
how many tokens.
How many tokens? Okay.
Sorry. How many tokens have been trained on, right? How many different combinations, right? So how much input was given? So a billion parameters is a big model. It's not a small model, right? It's a very good model. It's considered LLM at a billion parameters, right?
Yeah.
I think less than a billion, I think it's called SLM or small language models, right? But interesting thing is, so they're the first company to do a billion parameter model. And then you have Prime Intellect, which is the first company to do a 10 billion parameter model. 10 billion. That's a big step.
It's like an order of magnitude, that order.
It's one order of magnitude.
Yeah.
Better than a billion.
What is that like? What, practically speaking, I mean, again, like I'm not an AI nerd, so like these things I'm sort of learning about these things. When you step from a billion parameter model in GPT-4, which is already pretty good. I mean, like a lot of people use GPT-4. Most people I know, use GPT-4 and YouTube, and like GPT-01 is also very good. Now, going to a 10 billion parameter model, like what will be the noticeable difference that people will?
Oh, quality of results, accuracy. Yeah, so you have less hallucination, you have highly accurate like output. It's a better model.
Yeah.
So, and also the precision matters too. So the higher the precision, more accuracy you get, right? Yeah. In general mathematics, right? Like the longer you have after the dot, you have higher quantity, right? So that how deep you can go into the search, right? Yeah. That's precision. So FP16 or the floating point 16 is highly precise, but it takes significantly larger amounts of data. So your weights are significantly larger than, let's say, a 8 precision,
right,
or 4 precision, or even 1 int. So if you want really fast response, you want to go with like 1 int, like, but if you want really highly accurate response, you want to go with highly like FP16 or something. But if you're doing, so depending on what the use case is, if you're doing self-driving, you probably want like, low precision because the reaction time has to be good. So it's trained on less amount of data, but it's only driving data.
Yeah.
It doesn't know the rest of the world. It doesn't need to, right?
Yeah.
So depending on how you're using the model,
find some weird vulnerability that like exploits that blind spot, right?
Yeah. So I hope that a car that's driving doesn't need to know anything else besides how to drive a car, or something that's performing a very specific type. That's why you have small models that are better than large models, because they can perform much better, because they have less data and more focused data to be trained. In particular, so you can find a model that can only math, right? That's way better than GPT-4. Yeah, because GPT-4 is a general purpose model. Yeah, it's so large and so big. So the higher the precision, the slower the response time comes, and the bigger the weights are. So today we have Prime Intellect that's doing 10 billion parameters, right? And then potentially you'll have 100 billion parameters. And the 10 billion parameters, I think they're already like 15% complete, and they only launched last week. So people are yearning to give compute because they want to be part of this revolution. And Prime Intellect is very exciting because, again, they just use Akash. I'm not an investor or anything in these projects, right? I just love the fact that they've cracked a nut on decentralized training.
Yeah. So they're using Akash to build this template.
Yeah, both Nose as well as Prime Intellect use Akash. Okay. So we're talking about demand, where is demand coming from? Prime Intellect is one of the big demand drivers because this training is happening quite a lot.
And so who's where's the supply coming from?
For Akash?
Yeah.
So a big supplier for Akash is Foundry. So we have about 70, a little over 70 providers on Akash, and growing set of providers. A big one is Foundry Digital. It's owned by DCG. So Foundry, Foundry bought a bunch of A100s, H100s for crypto mining some time back, and they just showed up on day one when we launched with like a lot of GPUs, and I was like, wow. I mean, I don't know whether we have demands for them, but they somehow stuck around, and they really like the whole like deep-in arena. So they have a whole page called Foundry Accelerate that's dedicated to Akash and Tensor. So they supply quite a lot of Akash, nodes from Akash. We have Oblivious, we have Valdi, there are a lot of, what happened last year was, so there was a huge GPU crunch, right? It's no secret. It was impossible to get GPUs on Lambda. I mean, you need to get into the large contracts with a lot of players. Everybody wanted GPUs. Elon Musk going and purchasing 100,000 GPUs, and or H100s rather, and like now we saw Meta purchasing like 300,000 H100s. So there was a lot of demand that created an incredible supply crunch for GPUs. So that led to a lot of opportunists, like looking at potential ways to make money. So a lot of these business people that know how to get financing, started getting these and how to do business deals, started getting allocations for like small quantities, about 1,000, 2,000, 4,000, whatnot, to supply to the AI companies, right? So, and a lot of them ended up, creating these companies with extreme like saturation and fragmentation and the demand quite didn't catch up to the expectation. So now we have an oversupply of GPUs in a weird way, but these GPUs are not very usable because you need like large interconnected clusters to do meaningful training, and not everybody is doing training. It's only like large companies like OpenAI and Anthropic of the world are doing training. So what happens to all these GPUs now? So now there
brings the price down.
What's that?
Like mathematically, it just brings the price down.
It does bring the price down
if the supply is available.
So the price is very interesting. So if you have large interconnected cluster, the price is still up. But if you have a bunch of loose GPUs, the price is down. So it's very hard to commoditize H100s because the dimensionality is so huge that, differentiates pricing. Like you can't have an H100. So, I mean, you have the interconnect, you have the, you need to have the networking, you need to have a lot of other components that price an H100 cluster, not the chip alone. The chips can be like, commoditized. I mean, a chip is chip, but how do you commoditize the service, right? So the energy needs too. So it's quite a lot of like, commoditize on an hourly basis. You have energy costs, right? So in US, you have 20 cents an hour. I mean, 15 cents an hour, I think is the average for a kilowatt hour, basically. And each H100 consumes about 1.2 kilowatt hour for both for the chip as well as the cooling, in generally speaking, general terms. So, and then you have the chip cost alone, right? So, you can say if one wants to amortize their chip within 2 years, I think the price is around $2 an hour, roughly, including the energy cost, right?
Because an H100 is like, what, 40 grand?
32. 32. And if you like buy volume, I think you can get to 28 or something. Yeah. So if anything less than $2 an hour, you're losing money. Akash, we have chips for $1 an hour too. So there are people that literally are like, well, I just need some money.
Yeah.
So that tells you the market is not there's oversupply of chips now.
Okay. Interesting.
Very.
So there was a really high demand, or was that, I mean, that like 2 years ago, was that demand real, or was just like people stockpiling GPUs because they anticipated an increase in demand?
So the demand was real.
Yeah.
But the stockpiling was also real. The hoarding was real too. And a lot of times what happened was these companies got ahead of themselves, and it was impossible for Akash, even for us to go get these GPUs, because people were like, we don't want to just give you a GPU. Oh, you're crypto, we don't touch you.
Yeah.
It's still coming off FTX, right?
Yeah.
And now everybody's like begging us to like take the GPUs, It's kind of crazy. Like Lambda Labs wouldn't even talk to anybody. They were so up their noses, right? Yeah. And now they're struggling to like sell the GPUs. I think they're selling their GPUs for like $1.50 an hour or something. And still they can't sell them, right? So but we still need a network that can aggregate GPUs because there are a lot of GPUs. So they're taking whatever they can get. Fortunately, we're seeing an interest in H100s now because of Llama 3.1. And it's a big model. People want H100s to host them. But the only problem is, are these H100s in the right location, the right bandwidth? So there's a lot happening. But I guess like the distributed trading is going to be very, very promising. So if you say the marginal cost of chips are going to come down, especially with the oversaturation, the cost of decentralized training is going to come down too, right? So which is amazing. So Llama 3.1, for example, was trained on 30,000 H100s. So can we get 30,000 H100s for $1? That's like $30,000 an hour. It's not bad if you think about it, right? I mean, sure, it's a lot of money, but if you're getting me a 30,000 H100 cluster for $30 an hour, $30,000 an hour, that can create a 400 billion parameter model.
How many hours did the trade cost?
I think 2 months or something.
Okay.
Yeah, it's not bad.
So like the total cost is
so per hour, dude.
Yeah.
Do the math.
We'll do the math and we'll
later,
put it somewhere.
Yeah. It's not that bad. I think I did the math. I think you can train, if I remember correctly, don't quote me on it, I think you can train a good llama equivalent for about $50,000. Sorry, $50 million. Apologies,
Yeah.
$50 million. That's not a bad price if you think about it. Like like decentralized networks have the money. BitTensor alone is like $4 billion market cap, right?
Yeah.
There's a lot of money in crypto that if we all pull together, we can train the next, a trillion parameter model.
Yeah.
Fairly well.
So let's go into this then. I mean, I want to ask you also about we've been talking about the decentralizing the marketplace for producing AI models and for inference. Now, like, what's the next step after that? It's like building a model, building a decentralized model that is not controlled by any one company, that doesn't fall into the hands of like some big corporation that uses our data and that can use it against us, perhaps. I mean, there's also these things that are at stake, which overlap with a lot of the concerns that a lot of folks in crypto have about the way technology is progressing. So talk a little bit about like what the vision is there.
AI is such transformational, right? I mean, for the first time, we have a technology that influences how we think, because you don't question the AI results, and sometimes you may, but most of the time you don't, and it's very dangerous because now we are entering an era of digital feudalism, right? Especially as we get towards AGI. Whoever has AGI controls the world.
Yeah.
Because we're already seeing some variations of AGI in the crypto itself. We saw what happened with GOAT, the meme coin. So this new meme coin was launched last week, I think, by Truth Terminal. I think Mark Andreessen seeded it about $50,000. It went and created a meme coin called GOAT, and the GOAT is about $300 million market cap now. And it's actually making money. People are selling this stuff. It's tweeting. It's created a whole community. It writes all these wicked tweets. But that's a real impact on real commerce and in the real world. I think this is the first time you're seeing an example of crypto, of AI driving an asset price, right? And that's just the tip of the iceberg. Imagine, and it's not complicated to build something like that, right? So it's fascinating. Truth Terminal is on Twitter. Follow it. You'll see the tweets. It's actually pretty good. It's very engaging tweets too. So you're gonna see things like that as we get towards AGI. Now the question, there's going to be a whole proliferation of meme coins now, AI meme coins, and as sad as it sounds, but that's the truth and it's the reality you're going to face, right?
Yeah.
So you can imagine what a more advanced AI can be in terms of playing the stock market, playing doing all kinds of things that are impossible by humans, right? So we are entering an era of digital feudalism. The question is, who are these the lords and who's going to be peasants? Is it going to be few people that are going to control this technology, or is it going to be the people that use the technology, that want to control the technology, right? So I fall on the latter, and obviously we're building decentralized systems to avoid something that could deliver a digital feudalistic society. But the challenge right now is, so far the challenge was how do you get enough compute to build? Now we have a problem solved. And second is, how are the technologies that can leverage this compute to actually do training? That is solved. Now the third problem is, what is the incentive for someone to fund the development of to train AI? Why would I give my money to this whatever decentralized network? So what's the incentive? If I get some degree of profit sharing, yes, that's a good incentive. So now there's a lot of work happening, and some companies claim to have solved this. I'm not going to name them because I'm still doing my due diligence on these companies. But there's a lot of work on fractionalizing ownership of a model. If I contribute compute to the model, I should get a share of the future revenues from inference, because inference is how you make money, and training is how you invest, right?
Yeah, it's like tokenizing real estate.
Exactly.
Anything.
Yeah. So this is an easy model, but the challenge is, how do you keep the model open source, but not weights open source, not open weights, but open code?
Yeah.
In fact, how do you even fractionalize? Fractionalization is a layer on top. That's easy. But the challenge is, how do you keep the weights private, but keep the model open? And I think that's being solved. And once you solve that, now you have an incentive mechanism to incentivize ownership of a model. And I think that's going to kickstart a whole new revolution. There's going to be all kinds of different models that are better than others, and there's going to be a lot of competition. And networks like BitTensor is creating this monetization too, which is phenomenal, right? So I think BitTensor, what it's doing, I'm a big fan. I think they're seeding model development, and they're attracting a lot of traditional AI folks to do model development in crypto.
Yeah.
And that's going to be very, very important. I think we're in this really exciting time for decentralized AI. I mean, there's a lot of like scammers out there, but there's real work happening with training, with inference, with distributed training, with distributed inference, and model ownership. But where we're going, and that's the exciting part, right?
What does it unlock? Like, what does decentralized training really unlock that centralized training doesn't have?
So the main thing for me for decentralized training is open biases.
What does that mean?
So today, GPT or OpenAI, most of the OpenAI training happens through reinforcement learning, right? So you have faults, you have, basically situations where a human has to intervene and tell what's right to the AI.
Mm-hmm.
So depending on who this human being is, the AI is going to behave that way. So we saw what happened in San Francisco, especially with ChatGPT, the earlier version of ChatGPT and Google Gemini. It's heavily left, right, and heavily like trained by the people that aligned to left ideology. So it's famous. He wouldn't say anything bad about Biden, but he would say bad about Trump.
Yeah,
right.
It's like these weird tweets that you see where like it's asking, why are you proud to be white or why are you proud to be black, and it gives you like these different answers.
And Google Gemini was particularly bad because it was like you would ask it to create image of founding fathers. It would be like black women, like. Yeah. I mean, it's just really bad because that really shows you the biases that people that train. So the main important thing is open biases, and we want to have a say.
So open biases means that everybody gets to contribute to reinforcing the model, and so therefore the biases are, in theory, supposed to be more balanced, unless the people that are trained, unless there's a bias towards people who are for the people who are training this model to be either one or another kind of geopolitical. I mean, I think that what's going to happen is we're going to have like models that are like either sort of leaning towards one type of sensibility or political ideology, and models that are going to lean towards another, and like the existing echo chambers in which we're in are going to be catalyzed by the models that we're using. I mean, that's how I think logically how.
But at least a free market that determines, right? At least we know where the biases are. Right now we don't. Yeah. Right now we don't know who trained them. We don't know where the biases are. We don't even know what system prompts.
Not any better. It doesn't make for a better world.
But at least it creates for a fairer world.
Yeah.
Right? Like it's open world. At least
we'll see if it's fair.
But there's also like to your point, right? So there is examples of like this Microsoft AI, I think it was Sophia, like that was launched on Twitter and became super racist.
Yeah.
Like with like a week or two, right? So there could be that outcome too. I mean, I'm not saying, and the world could be the world. I mean, depending on how you look at it, either the world is a really bad place or the world is a really good place. But we'll see, right? But at least we'll know, and it's not controlled by a few. That is in a closed room. And second is the data and the quality of the data, right? Like a big thing today is most of the data is not on the internet, it's actually on our phones.
Mm-hmm.
Maybe Apple has all the data, I don't know.
Yeah.
But at least it's in people's hands. And how do you reach that data while preserving privacy is a critical aspect of training, like in particularly medical data, right? So if you want meaningful medical diagnosis systems, right now, big challenge to get access to high quality data that's anonymized, right? So if there's an incentive for me to share my medical data,
paper probably.
Electronic, scan, but if there is some incentive mechanism that's going to incentivize me to provide my medical data and guarantee my privacy, I would contribute because I mean it's greater good. Like if it's getting me better diagnosis.
Yeah.
I mean, there's an example recently which was amazing. They detected a lump in someone's breast, a breast cancer patient, 5 years ahead of time before they could develop into a bigger tumor. That's life-saving technology. And imagine So what AI does, it's not going to replace doctors, but it's going to make doctors do more with less time.
Yeah.
Like imagine most of the world doesn't have access to quality healthcare, right? Even Canada doesn't. Like even in the developed world, it takes a lot. It's very expensive. If you can reduce the cost of healthcare and improve access to the healthcare, and that's something that I want to be part of, right? And if you incentivize and make it fun, even better. Like WorldCoin showed that giving identity can be fun, right? Like, it's giving some incentives back.
Yeah.
With crypto has a phenomenal incentive network. It's really good at that. So if you can bring the crypto crazy degen incentive mechanism to healthcare and train a decentralized healthcare system or a medical diagnosis system, that's fair and private. I think that I'm not going to trust OpenAI with my health data. No way in hell.
Is the future,
right?
in the future, do we have a generalized model that is good at everything, or do we have a model that's very good at utilizing specialized models?
That's $1 billion question everybody's trying to answer. I mean, that's a big question.
I just have that question right now. It must be pretty.
Yeah, that's a big question, right? So we don't know, right? And so there are different theories depending on who you talk to, right? So either you're the big model camp or in the small model camp,
Okay.
right? I like to believe, it's my personal opinion, right? So I think it's going to be a lot of small models that are going to come together to essentially create a multimodal mechanism.
Yeah.
Because small models are inherently good at doing small tasks. So if you consider that humanity evolved by like groups, lots of groups of people contributing small amounts of skills that they're good at.
Yeah.
That's how humanity grew as a big...
Feels more intuitively correct.
Yeah.
Like it feels intuitively correct to think that specialization is what moves us forward in any kind of field. You need specialization in order to move forward. And so even for an AI, like if you consider that an AI wants to make progress, it has to be specialized, or at least I think with my limited knowledge here, is like it has to be specialized in a specific task in order to make progress, and then report back, say, like to some kind of, general model about like, I don't know, knowledge. But this is also how society works and how information transmission works and how knowledge growth works.
Or you can say like small models can reinforce a large model.
Yeah.
Essentially.
Yeah. Exactly.
Right. So there's that theory as well. So it's like, so we don't know what but it's still a large model.
But this is exactly how society progresses. Like you have like industries or like, people who specialize in a specific field, say, I don't know, quantum physics. And then, they go on and like build a plasma reactor.
Yeah.
Right. And that's like highly specialized. And then it comes back and then like that progress comes back, is shared and improves the general kind of nature of humanity, right? Yeah. Because we have abundant energy and then we're able to build upon that.
Yeah. The FOX25 gene, the one mutation that happened that made humanity retain knowledge that chimps did, that basically created humanity, right? So that sort of like, I mean, it's very parallel to how humans evolve.
Yeah.
Humans didn't evolve because of bigger brains. I mean, Neanderthals had bigger brains, technically. But Homo sapiens evolved because of diversity and mixing. Lots of mixing throughout thousands of years.
Yeah.
And I think we are the only ones that can like share the knowledge, and we have knowledge retention and sharing mechanism. So I like to believe that I'm part of that camp. But also like, so where we're going is it's a crazy world, right? So today we saw, GPT-3 was trained on a 10 megawatt data center, right? So you can get 10 megawatts, hard to get, but you can still get a 10 megawatt data power capacity.
Yeah.
I think GPT-4 or the next version is going to be trained. The Grok at least is being trained on 50 megawatt data center, the Memphis data center, Elon Musk's data center.
So Grok is Twitter's or X's.
Yeah, X's AI model.
Okay. So their new model is getting trained on.
I think Grok 3 was trained on 50
okay.
megawatt. So correct me, I'm a little hazy on the details, but
Grok 3 is like not great.
It's okay. It's actually pretty good. It's except for if you remove all the system prompts, the open source version is pretty good, right? I mean, it just tries to be too funny and like, so that doesn't really come off well.
Yeah.
But it's a big model, and it was trained on.
Is it only Twitter? No, it's trained on like general information, not just Twitter?
I don't know the details. I mean, they haven't disclosed the training set yet. Or they, I mean, I didn't disclose, but it's a larger model, right? So it took about 50 megawatt data center. So the notion is that every year the amount of power we need is growing by half an order of magnitude.
Okay.
Right. So Grok was 50 megawatt data center. You don't have 50 megawatt supply in a single source. So they literally are burning diesel. Like Elon Musk burning diesel.
And people are concerned about crypto being
bad for the
environment.
No one's talking about crypto not being bad for the environment. I think people are falling on AI now. They're not writing it yet because everybody likes AI.
Yeah.
People didn't like crypto. But no one's talking about like, hey, they're burning diesel to power an AI data center. Anyway, the next model is going to be 250 megawatt, right? If you go by this like prediction.
Yeah.
And a model after that, and the next year is going to be 1.2 gigawatt. So it's a gigawatt capacity. To get anything beyond a gigawatt, you need a nuclear reactor.
Yeah.
You can go use solar, but solar, a 2x2, so a square mile of solar panels generate about 2.2 gigawatt capacity. So it's possible.
Yeah.
But you need continuous energy.
Yeah.
So you need to have batteries to store them, right? Well, to store 2.2 gigawatts of batteries, you need, in the sun, they get really hot. I mean, lithium-ion batteries tend to explode. You need cooling.
Yeah.
So the amount of energy you need for cooling the batteries may not be, it's detrimental to the amount of energy you generate. So it's not actually possible to do solar panels. The only way to get that much amount of energy is to go solar, also nuclear.
Yeah.
So Microsoft bought a nuclear reactor, the 3 mile long in Pennsylvania, to power the new data centers. Oracle is building new data centers, new nuclear reactors to build the next AI data centers. So I think U.S. has approval for 19 new nuclear reactors now.
Jesus Christ.
The U.S. in total produces 4.4 trillion watt capacity now. We did not need to produce more energy till now. But now we are seeing an entire revolution in like energy. So, I mean, China has a double our capacity.
Yeah.
So we need to like ramp up our energy, and there's a whole nuclear revolution now happening silently. We're not talking about. I think it's a good thing because energy costs in the US are extremely high. I mean, on average, I think we're doing like 15 cents a kilowatt hour. California is like 30 cents a kilowatt hour. So nothing is happening in California. Texas is 10 cents a kilowatt hour. There used to be a time in America, we used to call it too cheap to meter. So we need to get back to that. So I'm really like excited for lower energy costs, because with lower energy costs, you can solve a lot of world's problems. We can solve desalination of water. We can solve the water problem. If you solve the water problem, we can solve a lot of problems, right? So I think this whole AI revolution is going to end up actually great for humanity in general, because it's going to bring the marginal cost of energy significantly lower. That presents another problem. It takes about 10 years to build a nuclear data center. I don't think we've gotten
a nuclear data center.
Yeah, sorry. So basically a nuclear reactor that powers that data, right? Yeah. So it takes about 10 years. I mean, I don't think we've gotten faster because there's a lot of regulations, it's quite a lot that goes into building a nuclear reactor, right? So we don't have 10 years to wait to build the next generation of AI. So I think what's going to happen is there's going to be a lot of these small data centers like I talked about that are everywhere that need to be connected. And if Dialoco or like distributed trading is solved, we can actually use a highly distributed network to develop the next AI model.
Yeah.
And that's why I'm very excited and very bullish on decentralized AI, because considering the energy constraints that we have, we're going to continue building nuclear reactors. There's a lot of investment that's going. There's a lot of finances happening. I don't think that's going to stop, because the energy needs are just going to be so high. By 2030, AI is going to consume 20% of U.S. electric grid, right? And that's a given, right? But I think in the meanwhile, we have an incredible opportunity for DeepN to really thrive, the decentralized GPU networks to really thrive, to take advantage of this nuclear, speed to build a nuclear reactor, but also pursue a dystopian setting where they're nuclear reactors powering AI data centers. If you picture that in a movie, that is creepy, right? Like you have literally uranium powering AI. So it's like, I think it was Terminator that we had this like nuclear reactors and whatnot. So we're going to that future very soon, like it or not.
Yeah, this whole conversation has just made me a lot more bearish Europe because of the whole like,
it's sad
kind of, debate around nuclear.
France is doing great.
I mean, France is doing okay. I mean, they're building new reactors. Germany is not. I mean, from what I've seen and what I've heard about like fusion reactors, I think like that's a long-term future, but
future is always 10 years away.
Yeah, it's very long-term, right? But I think that like if you look at like the next, sort of millennia of human civilization, I think probably that's one of the ways that we're going to be able to generate.
Yeah, nuclear is the only way, and it's already starting in the U.S. I mean, so investments are happening. I mean, I saw some banks that are like financing quite a lot. If you talk to a lot of Wall Street folks, they're like buying a lot of. I mean, when Microsoft announced the what do you call that 3 mile long, I think it's
3 Mile Island.
3 Mile Island is called in Pennsylvania. Uranium stocks went up like quite a lot. So there's money flowing into building nuclear reactors. And I think we're going to really reduce the price of electricity to a point that it's going to be too cheap to meter. I think that's going to be a reality. I'm really excited about that because, I mean, I want to see human civilization reach type 1 status in my lifetime, right? So
ambitious.
I mean, I think it's going to happen. Like, and the only way type 1 is defined by type 1 effective civilization that can consume all the energy resources on planet Earth. To a point that we can accelerate humanity to explore space and can do a lot of things, right? If we reduce the marginal cost of energy, that is going to be fundamentally great for humanity to progress, right?
The problem is alignment. Like the antagonist to the
degrowth, folks.
The degrowth. I mean, we could go on forever with this, but I think that at the same time, the technology is moving at an incredible pace, and AI is also like moving at an incredible pace. I worry that the social division that exists, that is perpetuated by algorithms, like unless we fix the algorithms, but I think that we can't fix the algorithms unless we change the incentives. We continue to be like divided. And I mean, just like, I'm oversimplifying here, but I mean, if you look at like the Chinese model versus sort of what's happening in the U.S. and Europe, and the level of sort of leadership and alignment and long-term thinking that goes into that particular society versus sort of progress in the Western world, I'm not hopeful that like I think we can't like problem is we can't get our act together. We can't like get people to have a common project. And that makes me a little bit more pessimistic about the future of humanity.
I have a different thought process. I mean, historically, U.S. has come together in Manhattan Project and in so many different cases. I mean, there is, of course, we can't compare with China in terms of how fast they can build infrastructure, right? They can speed up a nuclear reactor in a matter of a year. I mean, like, 3 years that we can.
Like, hey,
they already have like double capacity. They're building like, I forgot the stat for, but they're building like every year or every 3 years the entire capacity of Europe or something like that, like the energy, right?
Europe is declining.
Europe is declining. I mean, Europe is a retirement home at this point, right? Europe always had its ups and downs, so it's historically like very aligned. Like in Eastern, always had its like terms of, I mean, like in pre-colonialism, China and India arguably had like 50% of global GDP, right? So historically, there have been like ups and downs. But right now, what China is doing is very interesting thing from a geopolitical situation. So anything beyond, I believe, 7 nanometers, is banned, is export controlled to China. So you cannot send them chips. So they're developing indigenous chips now. We talk about Huawei, and Huawei is actually an incredible company for all the things, besides being controlled by Chinese Communist Party, but they had their hands tied on the back, and they're making incredible progress, right? They have such an amazing like market share. I forgot what it was, but it's majority market share in all telecom chips, right? And they are developing. They have 7 nanometer capacity, and the rumor is they have 5 nanometer capacity. And even US doesn't have 5 nanometer capacity. Only Taiwan has, right? TSMC, that is.
Yeah.
TSMC has 3 nanometer capacity, right? So we are finding it very hard to export the technology back to US, even though we invented it. I mean, Intel invented that stuff, right? Like, it's sad to see Intel going down. It's sad to see, like, I think West has lost its way in issues that are, depending on who you talk to, but, you know, I don't want to take a political stance, but issues that may not be contributing to human progress in the way I see progress in terms of technological acceleration.
Yeah.
Right?
So, like, I mean, like, when, like, 2 weeks ago, like, we, you know, the super heavy booster, you know, that whole thing. I mean, I think most people in, you know, in my surroundings, and certainly the people like in my neighborhood, don't even know or care.
Yeah.
I thought, like, this is an amazing feat of human progress and engineering. And I turned on the news next day, and it's like, not a peep.
Not a peep. The president didn't congratulate you, like, it's...
Well, in France, right? I mean, it was so, but yeah, not a peep. And possibly even people who did know about it were probably like, how, you know, complaining about it, about how it's like, you know, Elon's latest whatever. So yeah, this mindset is a little bit...
I think China competition is a good competition. I think free market, though, is playing out, right? China is out accelerating, and they have their own chips now. Some of the models are way better than the Western models, right? So the AI is very different.
Yeah.
It's very local. It's very indigenous to China.
Yeah.
They're very good at image models. They're very good at image recognition. Why? Because surveillance, so they're very good at video models. So I think there's going to be like a very fascinated East AI and West AI.
Yeah.
I'm obviously bullish in West AI because we're more free people in general. I think freedom in thought is very important for innovation. I mean, West innovates, China replicates, right? And Europe regulates. I'm generally bullish. I think like we as a free market is coming together, and there's also a notion of like we need to accelerate in California, especially, right? There's this degrowth mindset, but there's also EAC mindset. Like we need to accelerate as fast as possible. AI is going to let us accelerate. Like you yourself, you told me earlier that you're coding this app.
Yeah.
Imagine doing that without AI, right? So you as CEO and as a leader of a company that doesn't have time to sit and write code is able to do more. So AI is a time machine. It lets you buy back time.
Yeah.
That's why I'm like super bullish on like
a huge time buybacker.
Exactly. So what happens, the two ways to look at AI, right? The degrowth people, the way you look at AI is going to take our jobs.
Yeah.
But the growth-oriented people that look at AI is going to be like, it allows us to do a lot more with a lot less time.
Yeah.
So I belong to that camp. I always have a million things to do. Like if you give me time, I can do so many things. Time is my biggest challenge, right? If AI lets me get more time, I can accelerate myself. I write code too. I mean, I was not writing much code like last few years, but now I'm writing a lot more code because with AI I can do more.
Yeah.
Everybody can do more. I think people are going to realize that. They're going to be, of course, classism where people that know how to use AI are going to out-accelerate people that don't use AI. So then people that don't know how to use AI will have no other option to use AI, right? Like back in the day, internet was the same thing. People that use internet knew how to use internet. People didn't know how to use internet, kind of were left back, and they had no other option except to use internet. So a free market system will eventually work. It may take longer. It may take a few events that may not be ideal in terms of progress, but those events are going to make us realize. And America's always had its ups and downs, and like so, it's historically a big student of history and a big fan of history. So historically, we had so many. It was worst, right? Like we had Civil War, we had so much misalignment. But eventually, we all came together, and the West in general always figured out how to do these things in a well. And East, we look at East as this lens of communism, but it's a lot more complex. Like if you go to China,
absolutely,
yes, it's communistic, but it's a lot more free than what you would otherwise think. It's just different, and I think the moment we look at it from that lens, I think we're gonna have a better understanding of the world. So I'm overall very, very bullish to human progress.
LFG.
Let's fucking go.
Thanks, man. Appreciate it.